Hello students, welcome back to my YouTube channel Virtual School. This is the second lecture of electricity and its effect. In the previous lecture, we have discussed the introduction part, electricity the most convenient form of energy, and the third topic which we discussed earlier was electric charge and current. So today we will be discussing electric potential and potential difference. So this is the outline of in this topic there are three subtopics which we will discuss today, which is electric potential. The second one is what is meant by a potential difference, and the third we will be discussing potential difference measured, how the potential difference is measured. So moving to the first topic, that is what is electric potential. So electric potential is also called electrostatic potential or simply as potential. So basically in common language we say potential, but actually it is called electrostatic potential or electric potential. So let us discuss what exactly is electric potential. So the definition of electric potential at any point in an electric field is the amount of work done in bringing a unit positive charge, which is also called test charge, from infinity to that point. As the definition is very much clear, whenever a unit positive charge is made to move from infinity to that point and a work is done from bringing that unit positive charge from the point of infinity to that point, so it is actually the amount of work done in bringing a unit positive charge from infinity to that point. So this is the general concept of electric potential. Electric potential is denoted by capital letter V, and it is a scalar quantity, which means it has nothing to do with direction. Let me tell you one more thing. Potential of a positively charged body is always positive because the work done on the charged body while sorry be- because the work done on the charged body is positive. Similarly, the potential of a negatively charged body is negative because the work done on that charged body is negative. The work done is negative. So moving to the next slides, the potential of a charged body determines the direction of the flow of charge when made a contact to another body via a conductor, which means that whenever we connect two body where both bodies are at different potential by a metallic wire or a conductor, then the direction of the flow of charge totally depends upon the potential of the two body. That means the charge will flow from the higher potential to the lower potential. Moving to the topic of units of potential. Potential, as discussed earlier, that it is denoted by capital letter V, is equal to the work done by charge. That is, the work done is always measured in joule. The unit SI unit of work done is joule, and charge is coulomb. So if work done is 1 joule and charge is 1 coulomb, then the SI unit of potential becomes 1 joule by 1 coulomb, which is equal to 1 joule per coulomb. And the unit joule per coulomb is also called volt, generally denoted by capital letter V. Hence, the SI unit of potential is also volt, denoted by V. Now there is a second assignment of this chapter, that is, what is the definition of 1 volt? I hope so you will do this assignment. Moving to the next topic, what is meant by potential difference? So till now we were discussing about electric potential. As discussed earlier, electric potential is the amount of work done in bringing a unit positive charge from infinity to that point in an electric field. So in electrical system, the potential difference between any 2 points in an electric field is more useful than absolute potential at that point. Let us consider a 2 point A and B, point A and B as illustrated in figure 3, point A, point B, which is present in an electric field created by charge Q. So this is charge Q, which is creating electric field around this charge, around this in this area, and this is the point of infinity. So if work done in bringing a charge Q from infinity to point A and B are denoted by WA and WB respectively, which means that if work done in bringing this Q charge from infinity to point A is WA, represented by WA given as here, and this is point B. For the same charge, if we bring it from infinity to point B, then the work is, obviously it will be different, and it is written as WB. So the potential at A, denoted by VA, will be WA divided by Q, where WA is the work done in bringing the charge Q from infinity to point A, and Q is the magnitude of the charge. Similarly, the potential at B will be represented by VB is equal to WB by Q. Then the potential difference which is created between B and A is given by the scalar subtraction VB minus VA, the scalar subtraction of VA from VB. So on putting the values of VB and VA respectively, we get that the actual potential difference between B and A point will be WB minus WA whole divided by Q. So this is the value of the actual potential difference. Moving to the next slide. So thus the potential difference between 2 points in an electric field is defined as the amount of work done in bringing a unit positive charge from one point to another. So this definition resembles to the definition of electric potential. The only difference is we are using potential difference instead of electric potential. So the potential difference between any 2 points in an electric field will be the amount of work done in bringing a unit positive charge from one point to another. If WB minus WA, if this whole quantity, if the value of this whole quantity is 1 joule, means the difference in the work done is 1 joule, and the value of charge is 1 coulomb, then the potential difference VB minus VA will be equal to 1 joule by 1 coulomb, which is equal to 1 volt. So the potential difference is also a scalar quantity, and its SI unit is volt, denoted by V. So we can see that the potential as well as potential difference both has got same SI unit, and both of them are scalar quantity. So now we will be discussing about the last topic of this lecture, that is how potential difference is measured. So here we can see that from figure 4, in which I have drawn a circuit comprising of conductor, resistor and a voltmeter. This is called voltmeter. So from this we can say that we can see that the voltmeter is connected in a parallel way, and this resistor is in series connection in between point A to B. So the potential difference between any 2 points in an electric field is measured by an instrument called voltmeter. So this is the general symbol of voltmeter, and we can see that the positive terminal of voltmeter is connected to the positive terminal of the circuit. Similarly, the negative terminal is connected to the negative terminal of the circuit. So voltmeter is generally connected in always connected in parallel to the point across the potential difference is to be measured. So this is the end of second lecture, and in the next lecture we will discuss about electric current, that is charges in motion, which will contain the subtopics like what determines the flow of charge, what is the direction of flow of electric current, and how is current flowing through a conductor measured. So these are few topics which we will discuss in the next lecture. Thank you.